Problem 66, Quantum Mechanics. The question is, a particle in the infinite square well potential V of x equal to 0, 0 less than x less than a, infinity otherwise, is prepared in a state with the wave function psi of x equal to a sine cube pi x by a, 0 less than x less than a and 0 otherwise. The expectation value of the energy of the particle is. In this problem, we have to find out the expectation value of the energy of the particle, which is in an infinite square well potential. The wave function is also given. First, let us write the given wave function a sine cube pi x divided by a. Now we have sine cube theta. We have sine cube theta is equal to 3 sine theta minus sine 3 theta divided by 4. Therefore, our wave function can be expressed in terms of the sine cube theta. Therefore, we can say psi of x equal to a by 4, then 3 sine pi x by a, 3 sine pi x by a minus sine 3 pi x by a. Now let us write the given wave function in standard form. For that purpose, let us introduce a term root of a by 2. Now psi of x become a by 4, 3 root a by 2 root 2 by a sine pi x by a minus root a by 2 root 2 by a sine 3 pi x by a. Now consider the terms. Root of 2 by a sine pi x by a is nothing but the ground state wave function, and root of 2 by a sine 3 pi x by a is nothing but the second excited state wave function phi 3. Therefore, psi of x become 3a by 4 root of a by 2 the ground state wave function minus a by 4 root of a by 2 times the second excited state wave function. Now let us normalize this psi of x. For that purpose, take the inner product of psi of x with itself and equate it to 1. You will get the value of a. Now it equals to 9a square by 16a by 2. Then inner product of phi 1 with itself plus a square by 16a by 2. The inner product of phi 3 with itself, and that is equal to 1. The inner product of phi 1 with itself is 1. So the first term is 9a square by 16a by 2. The second term is a square by 16a by 2. Since the inner product of phi 3 with itself is also equal to 1. Therefore, we can say 10a square divided by 32 equal to 1. This gives a is equal to root of 16 by 5a. This is our normalization constant. Therefore, our wave function becomes psi of x. Therefore, psi of x equal to 3 by 4 root a by 2, then root 16 by 5a, then phi 1 which is the ground state wave function minus root a by 2 root, then 1 by 4 root 16 by a, then phi 3 which is the second excited state wave function. Now on simplification, you will get the psi of x as 3 by root 10 phi 1 minus 1 by root 10 phi 3. That is, our given wave function is a linear combination of the ground state wave function and the second excited state wave function. Now we have to find out the expectation value of E, that is psi h psi. Now we can write it as expectation value of E is, if you take psi h psi, your answer becomes 9 by 10, then phi 1 h phi 1 plus 1 by 10 phi 3 h phi 3. It is phi 3 h phi 3, and the answer is 9 by 10 E1 plus 1 by 10 E3. Now what is E1? E1 is pi square h bar square by 2ma square. Therefore the first term is 9 by 10 pi square h bar by 2ma square. The second term is 1 by 10 E3. What is E3? 3 square pi square h bar square by 2ma square. That is 9 pi square h bar square by 2ma square. Now what is 9 by 10 E1 plus 1 by 10 E3? Let us do the summation and you will get the answer as 9 pi square h bar square divided by 10 ma square. 9 pi square h bar square by 10 ma square. Therefore we can say that from the given option C is correct.